design that you can start preparing for building, we need to get it in a form understandable by the laser cutter. We're going to be using Inventor, and all the steps are written out in the assignment 1 to 13. This time we're taking our information from the glider report and creating an outline for the shapes that we want to be cut out of the balsa wood. When we start Inventor, you will need to sign in with your email. I have made each of you a user, and you have to keep an eye on your personal email for the verification code. We are going to make a new part in Inventor, and we will sketch our lines in the proper dimensions. We are going to add a rectangle that represents the full piece of balsa wood, and on that rectangle we are going to use lines to create the outline of our wing, horizontal and vertical stabilizer. As you do that, I will remind you to keep in mind that your vertical stabilizer, really all the parts, have to go along with the grain of the balsa wood, which means you have to orient them in such a way that your leading edge is going to be parallel to the balsa wood. All right, let's switch over to Inventor and see how that works. When we have Inventor started, we are going to start a new file. New, and we are creating a new part. Our new part is going to ask us where in the three-dimensional space we would like to work. However, we are only focused on a 2D sketch, so up on the top menu, we're going to start a 2D sketch. You can select any of the planes you want. I'm used to using XY for something like this, so that's where I'm going to go. The first thing we should do is add a rectangle to represent the balsa wood piece that we have. So I'm going to select rectangle, and I will start at like the center and extend it out. I do have the option of typing in my dimensions, so I can type in 36 inches and then 3 inches for the height. When you hit enter, you do now have a rectangle that represents your balsa wood. On this rectangle, we're going to use the line tool to create our individual components. If at all possible, leave a tiny little bit of space in between your wing and horizontal stabilizer and vertical stabilizer. If you are using up the full balsa wood sheet, then you're not going to be able to do that. All right, I'll start by creating my wings. My wing is 40 centimeters span, but at this point my dimensions are shown in inches. Let's go ahead and change the dimensions by clicking on File, and then Properties. Let's see if I remember where to do that from. From here. Let me remind myself by switching over to my instructions here. To change our dimensions, we are going to click on Tools tab, Document Settings, and then we're going to change the length to centimeters. Tools tab, Document Settings. Tools tab, and then Document Settings. So we can change our units for length to be in centimeter. And apply. Okay, back to our sketch. We're using a line. My line is 40 centimeters wide. I do not want that line to be directly on my ledge, if at all possible. Sometimes it is not possible. In this case, I think I actually have to go on that. I'm going to set my dimension to be 40. And when I hit enter, I have my line. My next line is already connected to this one. And I know that my root chord going straight down is 5.3 centimeters. So making sure that my angle stays at 90 degrees, I can set my next line to be 5.3 centimeters. Next, I would have to go to the center of my wing, but I don't know what is my root chord, so instead I am going to hit escape. Now I am no longer adding lines until I select the tool. I do need that tool, and I need to start at like the midline of 40. As you move your mouse along that line of 40, it actually locks into the midpoint. I notice that as I get close to it, it is clicking into my midpoint. I will go ahead and add my root chord. My root chord going straight down at 90 degrees is 7.6. And sure enough, that takes me to the very edge of my balsa wood. Now I can go back to the right and connect to my wingtip. I have just added my taper on here. I need to do that on the opposite end, so I will select line, and from the edge of my line going down at a 90-degree angle, I need to add my root or my tip chord, which is 5.3. Of course, symmetric on this side as well, and then that needs to be connected to the tip of my wing. That right here is my wing. Now, I don't want the wing to be cut into two separate parts, so I will make sure that before I move on with my horizontal stabilizer, I take this root chord and delete it. I used it as a guide, but I really do not need it as a part of my sketch. I do not want to be cutting there. So I will try to click on delete. I could not delete this line until I removed all of the constraints on it. So a few times I had to right click on the line and then select delete the coincidence constraints. These were the constraints that I connected another line from this. I can now select this line and actually delete it. Hopefully, if I can read, there we go. Delete was up here. Okay, my wing is all done. Next, moving on to my horizontal stabilizer, and next moving on to my vertical stabilizer. I will mute myself and add my components. The vertical stabilizer is one that I want to make sure I show you. I am keeping in mind that the grain of the balsa wood goes from left to right. So the leading edge of my vertical stabilizer has to be oriented the same way. My typical vertical stabilizer will look like this. It looks like I have a root chord of 6 centimeters. I am using a sweep angle and a taper at the same time. So I do need a few guiding lines for this. My span is at 90 degrees, which I somehow could not get locked in. And then I do have a root chord of only 3.1. From the imaginary front of the wing down, the sweep angle is going to give me a gap of 2 centimeters. So I just added that gap. From here, continuing downwards, straight down is the tip chord of my vertical stabilizer, 3.1. And from here, I can actually connect back to my root chord. I am going to need, or I will need to delete a few lines, but I have to add one more line that connects the front of my vertical stabilizer to the tip. Certainly, I could have done a little bit of math and calculated those values instead, but I thought this was just a little bit easier. I can delete these guidelines now. I no longer need them. And as we are placing our vertical stabilizer onto our grain, we really need to rotate this. This is the leading edge. The leading edge needs to be parallel to the grain. So I have to turn it to be parallel to this line right here. I am going to use my select tool and grab all of these lines together. And I will go ahead and rotate them. I am rotating all of these components around this center point. And now I can turn it to allow for my leading edge to be a straight line parallel to the grain. There it is. We have rotated the vertical stabilizer so that the front leading edge is parallel to the grain. This is now my final sketch. My balsa wood is placed on the back and I do have all of my dimensions. I can finish the sketch and save the part. Make sure you know where you are saving your part. You can put it on your desktop, you can put it in your OneDrive, or wherever you can easily access it. Once we have this part saved, we are ready to actually make a drawing, which has to be in 1-to-1 ratio. To do that part, we can right click on the sketch. Let's see if we can do it this way actually. Now we're going to go back to File, and we're going to make a new drawing. Our drawing, we can use a template, and we need to select the size of the sheet. Our sheet size need to be D size sheet, so all of our material can fit on here. So if you right click on sheet itself, you can edit the sheet and make sure that its size is D. From here, we don't need to change anything else. We are ready to add our part. We are going to place a view, and we want a base view. I see a preview of my glider. So with this preview, I am noticing that the size is shrunk. I need to change the scale. My scale is going to be 1-to-1. With this scale, I can adjust my view. And state okay. We need to make a few more adjustments. The laser is able to use the outline of our shapes, but we do not need this framework that is already on the sheet. So over on the left hand side for our model, we are going to select the default border and delete it. We also do not need this drawing table. We are able to select this table and delete it as well. Okay. That is the only thing we need, just our part. At this point, we can go ahead and save our drawing. But instead of saving it as a DWG drawing, I want you to save that as a PDF. Let's do that in another way. We're going to click on File, Export, and then export it as a PDF. For this export, put it in the same place as you put your actual part and click Save. We now have a PDF that we can import into the laser and cut out the shape of the glider.